So one of the features we released in latest release in 144 is called response channels, and as the first feature, which it's a very interesting one, but also the first feature which for which we added the concept of preview, which is a new concept in Aeron, where we basically flag a feature as experimental until it's done, and allow ourselves to change it if necessary. There is like a flag, and we will gradually turn a response channel into the supported feature, so to speak. That's being said, this experimental feature is still supported. We just probably make some changes to them. So what's response channels? If you've been using Aeron before, you know that in order to send messages, you need publication subscription. So you need publication on one side, subscription on another side. However, you cannot receive back, right? So you basically need two pairs. So each side will have to repeat. And we want to improve on that and say, can we do it better? Especially around the fact that you don't have to expose a client's address server, so that you don't have to, for example, send a response channel in a payload or something to establish the connection back. It works with NAT, for example, network address translation. Docker is a famous one where you don't have to drop to like network host mode and stuff like that. So that's the main motivation. The way it works is, it is a new kind of MDC style mode, which is called response mode, where when you create subscription, you need to specify control mode response, and you see it doesn't expose anything and local endpoint which connects to. You can do it if you want to connect to a specific port, but normally you won't. And you just specify a server port that's going to listen to it. However, when you also create a publication to the thing, to the other side, you have to specify a new parameter, response collation ID, which is a subscription that you just created. This is needed so the media driver can couple the two and can follow the setup traffic and connection messages that goes through. On the remote side, you have a normal subscription that just listens on the port. That's where this publication goes to, right? So port 10,000, that goes there. However, the tricky bit is the support for multiple connections. So that's why we have, like in this example, handle connect, disconnect, where we say you're listening for every client that connect. We will create a publication that responds, again, using the same control mode response. That's basically the coupling bit, and it connects to an image. And this connection is necessary so that, as I said, setup connection traffic could be established between two nodes and can send back to the subscription that on the other end. And we remember association because whenever we reply, we need to reply to a particular publication. So it's still kind of needed here. And when disconnect, we clearly forget about it. And what I just said can be represented with another diagram.
Yeah, trying to make it easier to understand. So we drew a diagram about an hour before we started because we realized that it was quite difficult to understand what's going on. So for anyone who's set up a kind of bidirectional communication stream or is using cluster or using archive, this kind of the unidirectional paradigm of information flow for Aeron that works very well in a kind of market data distribution case, trying to establish a response channel is quite difficult. So the pattern looks a bit like this, in that you have the acceptor or the server side that will create a well-known subscription listening on port 10,000. The client will, it knows that up front, you configure it. The client also knows its own host name and a listening port on its side. It will create that subscription first. It will create a publication to the server-side subscription. It will send a connect message where it tells the server how to connect back to it. And then the server is creating a publication to create that back channel to the client. So in this world, the acceptor ultimately needs to be able to connect back to the initiator, and it needs that route. This is kind of quite difficult in a NAT world because, if that's on a completely different network, how do you establish that route back? So what it looks like, and I've done the spot the difference for you in this instance, to try and simplify the example. Instead of trying to kind of create that pair, we're handling it on the Aeron layer with channel URI parameters. You're not having to send that connect message in order to tell it where to listen. The initiator doesn't need to be listening on a well-known interface. It's establishing a connection effectively using the same mechanics as MDC underneath the hood to a kind of listening publication on the server side. That's how it's all kind of linking. So all of the connection from a client perspective is kind of directed towards the server, which is already kind of needing to expose those ports for communication. So we're hoping that this kind of response channels is going to simplify, ultimately cluster configuration, archive configuration, that being able to think of things as a server and a client without that back channel. And things like Docker, if you've ever tried to connect an Aeron cluster client to a running cluster in Docker on a Windows machine that's running in a VM, trying to establish that back channel from a networking perspective can be a bit of a pain in the arse. So hopefully a bunch of things become easier after this is in. We've got another one, overrun behavior, quite a subtle one. We're making more use of those kind of large log buffers that you're configuring when you're creating publications and subscriptions. So what's happening? The old behavior was that you have for those of you who've opened Aeron Stat, these kind of counter names will be familiar. You've got the kind of receive position and receive high watermark that dictate like where a stream has been received up to, where you've got data up to in your image. And then you've got sub positions that define where you've consumed up to. And then on top of sub position, you apply the receiver window, and that goes back in your status messages to the publication to kind of dictate the flow control window, and ultimately will kind of bound the production side. And so what would happen in the like prior to 144 is that when you're kind of sending data out to multiple consumers, the kind of rate of those receiver windows would change, and you can, in a max multicast flow control strategy, you could have things falling behind. And in the scenario where they fall behind for just a blip, it takes a bit longer to process a few messages and there's a burst of traffic received, it's quite easy to receive data packets that go beyond the receiver window. Before those overruns, and there's space to put them in the buffer. So we're making more use. What would happen before is you would get an overrun, the counter would bump, you would see that kind of data basically dropped, and ultimately the subscriber would have to basically do a NAC and get a retransmit. Now the data that is received beyond that receiver window is added in the buffer, so the subscriber can kind of work onto it once it arrives. It's not in a pathological slow subscriber case. We still recommend using kind of archive to be able to rate adapt between the two, but in terms of stability of clients that are just take that blip or might pause or might take a bit longer to process a batch of messages versus others, this should kind of increase the stability of those receivers in a multicast group or an MDC group.
It's half a term, right?
Half a term. So we're using that kind of an additional buffer. So in UDP world, that's 8 megabytes by default that you've got as an additional subscriber buffer.
Is there a parameter to
It will be a function of term length. So yeah, ultimately you can tweak it based on term lengths. But if you're starting to exhaust that available space, then I think you fall back to that pathological. Yeah, you're basically a slow subscriber that should be falling back to an archive to be able to rate adapt between the two.
Another place where this helps is where you have multiple, where you have a group of subscriptions on the same media driver, and then one slow one will take out the whole group. So this helps us that the group survives as well. So it's depending on the use case. Yeah, 0 days since DNS. I know some people in the audience who requested this in Aeron for many years to have DNS resolution to be asynchronous, and we finally have done it. So the main motivators are stalls on the conductor thread. So the way it works in Aeron, whenever you add a publication or subscription and you use a DNS name, it has to be resolved to an address so Aeron can establish communication, basically in sockets, right? And to do that, basically, it's a DNS query at that point. That used to happen on a conductor thread at the point of publication subscription being added. Well, some of you know that if you're running in the cloud, you might have stall for like 10, 15, 20 seconds, 30 seconds DNS query. And that would mean that the conductor is not doing anything else, like updating counters, which leads to flow control issues, which leads to clients disconnecting and all sorts of different difficult issues. And prior to that, you basically had to play with timeouts or configure your OS. Right now, we're going to do it in a synchronous manner. So we have a background thread, by default, just one. You can configure more than one to do it. And there are basically some smaller bits that we have to still figure out around the driver name resolution. But for a typical use case, basically, this is all asynchronous. It's done in C and Media and C and Java media drivers. So that should help tremendously with sources of pauses and the stalls on the conductor.
Yeah, because we were kind of, that conductor thread, while it doesn't do like very well, it mostly isn't doing the important work on the hop path, but it is doing things like updating counter values that impact flow control. So it does, after, if it pauses for long enough, then it creates kind of flow control problems. And we've seen kind of scenarios where DNS can go horribly wrong. The time it takes to get a result back can be in the multiple seconds that kind of can really impact, particularly in a fast flow, in a cloud type environment, that can cause real problems. So hopefully this will be another kind of stability fix for those kind of, particularly in environments where they don't have control over the DNS.
Another one is error resolution, when you have multiple active streams happening and they go silent because there's a change in a cloud or something. We need to resolve addresses, and particularly they come in swarms. There's a lot of them coming. So if they come in the same thread, so that's an issue. And being asynchronous really helps a lot. That's about right. Bunch of other changes. We improved the last couple of releases, things around debuggability, and got some smaller things like we have versioning for each component. So you can detect in, for example, Aeron start versions of your archive clients and stuff. You see, for example, where something is not yet migrated up to speed. We also have named clients. That's also a feature that's requested quite a lot. You can give a name to your client connection to the media driver, so you can distinguish the clients where they come from. We've done a lot of work on improving debugging messages and making sure they follow the same pattern. And if you enable drivers, in particular driver login before, you would see the cryptic ones, just the numbers 24, 47, minus 17. And you had to know what this thing means. So basically us, and actually all of us who could decipher. So right now we follow the same key value pattern, which is much nicer. We have nice things like, for example, snapshot duration tracking, where you can tell how long a snapshot takes in a cluster, or per service snapshot time, and a bunch of other stuff. And whenever you print configuration, that now all components will do it, not just media driver. So whenever you send support requests, you'll include more information, and we'll be happy with that.
Yeah, for those of you who don't recognize, just go one back to me, Trey. But for those who don't recognize that kind of frame in message, that's coming out of the Aeron agent logging that, I guess one of the things that Aeron doesn't do, and maybe surprising to people when it first starts up, is it's very quiet from a logging perspective. That's kind of primarily performance, and we don't want to pay the cost of doing that. If you haven't played with Aeron Agent, it is definitely a good way of kind of getting a view into what's going on under the hood. You can turn it on at various different layers, so either cluster, archive, and also even with like individual frames at the driver level to kind of get a sense of what's going on. I would recommend having a look at that, especially now that you can actually understand what it's saying. One of the things we've improved around cluster backup is this ability to use it to grab the kind of requisite data off the main cluster to be able to start up a new node. So it can grab the latest snapshot, and also the major change is that it will only grab the log from that point of the latest snapshot. So it's grabbing the minimal set. That can be used for node replacement if you need to grab that and replay it somewhere else. It will ultimately extend once you've got this in place. So it's a great use case for backup and kind of being able to kind of take a copy of the running cluster. It's using archive replication to get those snapshots and also that log. So it's kind of really streaming as fast as possible.
It only works once. So once you start it and you keep existing cluster backup, it continues from that point. But if you're seeding a node from empty, that's where this really shines. Oh, yellow little.
Oh yeah, so cluster standby, one of a bit of a plug, one of our premium features, node replacement, kind of replicating what the cluster backup was doing there, just to be able to get the latest snapshot and log. From a recovery node replacement point of view, cluster standby can do it even faster. It can do the same thing, transfer the latest snapshot and the log. It will be kind of running the state machine as well as it recovers. And then you have the ability with the cluster tool to be able to transition it to take over the identity of a previously existing node. So this kind of really allows those kind of scenarios where you're having to kind of repair a cluster after nodes go missing, being able to make that work. And this is one we've been kind of experimenting on over the last like 2 or 3 versions since 143, 144, and there are kind of new changes going into the next one around this kind of hot upgrade scenario in particular. This case where you want to upgrade nodes individually and then ultimately turn off the leader node and have an election triggered as a result. We've got to the point where this is a chart effectively of a cluster client sending messages into the cluster at around 10,000 messages a second, and ultimately tracking the latency of the responses back out of the cluster, which is just echoing messages. And it is we are stepping down the leader. We're kind of bringing it to a graceful halt. That means kind of turning off the consensus module, but leaving the archive and media driver running, so that a new type of frame with a end of stream header can be sent by that media driver and ultimately trigger the election as a shortcut rather than waiting for the full 10-second timeout. So we've got it down in this one. We see that gap there as the gap in processing from the client, and those messages ultimately kind of take a second to come around the point that you take the leader down and a new one is elected. And then we've got the kind of green horizontal line is bringing that leader back up, so that kind of recovery. So we're kind of, we're kind of, in the recent version, this is kind of slightly out of date now. We've kind of got it down to half a second from the second that it is now. And what have we got coming up?
Well, we are actually looking on migrating away from JDK8, and that's a big one. We're going to be asking you guys to tell us if that's going to break or make things. The primary reason for it is that the build tools and dependencies that we use moved away from that. And we're JDK8 bound, so we want to go to 17, I guess. That's the plan. It's one of the strategic decisions. We have to bring Aeron and tooling and Aeron up to that version. We want to, as I said, mature response channels. The work and archive client is done, is committed into 145. The cluster is still baking, so making sure we use basically dogfooding same features and kind of use them internally and simplify your life. Still keeping it compatible to the existing one, so it's not breaking anything.
A lot of those features that we're talking about have come up from customer use cases and people, our customers raising support issues, coming up with issues and suggesting improvements. This is kind of where we see a kind of constant stream of ideas coming in that we kind of really like to roll into the next release. So please, keep the ideas coming. We're also looking at building a tool around managing the lifecycle of data within the cluster, like retiring old segments of log that's no longer required for recovery, retiring old snapshots, and just effectively ensuring that you don't run out of disk space when you're starting to run the cluster for a long time. And Aeron Sequencer, which Dave will be talking about any second now.